we have here a sample problem number 1. Okay, so since this is rectilinear motion, the object or the car moves in a straight line path, such that for a short period of time, its velocity is equal to 3t squared plus 2t foot per second. So this is in imperial units, foot per seconds. Determine its position and acceleration when time is equal to 3 seconds. When t, so ingon diri nga, so when t or the time is 0 seconds, its position is at 0 meters. 0 foot. No. So this is a sample problem number 1 as P1. So in solving the problems, I would like to advise, take note first of what are the given. So here in this problem, we have a given velocity. The velocity is equal to this one, quantity 3t squared plus 2t. The units are foot per seconds. This is the first given. The second given is time. When time is equal to 0 seconds, the distance or the position s is also 0 foot. So we are as, determine the position. So what is as? So these are the given. So this is important in problem solving. You need to see first what are the given and then look for what is being asked. So we are asked what is the position. So position s, and then the acceleration. The acceleration a at the time 3 seconds. So ako lang ni S sub 3 to denote position S at 3 seconds and the acceleration A at 3 seconds. Okay. So now, we need to solve this problem. So, nadagan naman tag equation. So, ato ni siyang kuan, no? We need to remember the given equations before. So we have 6 available equations in this problem. The first thing is to know which equations to use. So among the 6 equations, we need to use which equations to use. Now, take note that acceleration is the derivative of velocity and the velocity is the derivative of position. Okay, so before akong gina-emphasize sa inyo ha, di ba? Position, ang derivative ni position, first derivative is the velocity. Second derivative ni position is the acceleration. So, si acceleration po is actually the first derivative of velocity. So, sa relation nila. Okay. To know whether to use the equations of motion with constant acceleration, we should check the acceleration, and in order to get that, we derive the velocity of equation. Okay. So, balik ha. Acceleration is first derivative ni velocity and second derivative ni position. Velocity, first derivative ni position. Okay, to know if the this one has a constant acceleration, we need to derive the velocity. Again, velocity is equal to 3t squared plus 2t. If we derive this with respect to time, we have dt over dt equal to 3t squared plus 2t. So, with respect to time, so this will become, the acceleration is equal to 60 plus 2. No? So, the acceleration, we have this acceleration, 60 plus 2. Okay. So, mani siya pasabot. This means that acceleration is a function of time and therefore is not constant. So, we're going to use the first set of equation. Okay. So, atong nakita diri nga dili constant ang acceleration. How can we say that the acceleration is not constant? Because dapat constant ra ang mabilin. So when we say constant in mathematics, these are variables, numerical variables. So they are only numbers. So dapat nabilin na nato diri is a constant, no, or the number. Since we have the t, it means that a is a function of t. So pasabot, as time increases, acceleration may also increase, in this example. So since this is not a constant acceleration, we use the first set of equation atong gibuhat. Okay. Another one to take note of is that the position is the antiderivative of velocity, and velocity is the antiderivative of acceleration. So to get the position, we integrate the velocity. Limits are actually given as conditions when t is equal to 0 and s is equal to 0. Okay, so moto siya, no? This is not a constant acceleration, so we use the first three set of formula. Katong v is equal to dv over dt. V is equal to ds over dt, and a, or acceleration, is equal to dv over dt. So, ang ingon niya diri nga ang position is antiderivative of velocity, and that velocity is the antiderivative of acceleration. Okay. So to get the position, we integrate the velocity. So mo ni siya. Para makuha na to si position, we integrate velocity. So so s prime is equal to ds over dt. So this is equal to velocity. So ds is equal to v dt, and then our velocity equation is equal to 3t squared plus 2t times dt. So ato siyang i-integrate. And then our limits is our time limit is from 0 to 3 seconds. And then ang ato ang distance nga limit is from 0 to s. So combining these equations, we have s minus 0 is equal to this one. Ato siyang ibalik. So by power rule, 3t squared, iyang antiderivative or integral, is equal to, so t cubed plus t squared. So this is from 0 to 3 seconds and 0 to s. So actually na s naman nato na. So s is equal to, at 3 seconds, so substitute na to ang time at 3 seconds. You have 3 cubed plus 3 squared. Our position after 3 seconds is equal to 3 times 3 is 9 times 3 is equal to 27 plus 9. So our final answer is 36 foot. So at time is equal to 3 seconds, our position is 36 foot. Okay? So determines position and acceleration. So at acceleration, we already have acceleration is equal to 60 plus 2. So at 3 seconds, 6 times 3 plus 2, our acceleration then becomes 18 plus 2. Acceleration is equal to 20 foot per second squared.